Hello, geometry students. Here's your lesson for section 3.3, Proving Lines Parallel with Missy McCarthy, math instructor at Okemos High School. In this lesson, you'll be able to use angles formed by a transversal to prove that the lines are parallel. You should be able to state the postulate or the theorem that proves that the lines are parallel. This next one is a biggie, that's why I highlighted it in a different color. You should be able to recognize when you need to use postulates and theorems or their converses, and you'll see what I mean in a moment. And you should be able to recite the converses of the corresponding angles postulate and the alternate interior angles, same side interior angles, and alternate interior angles theorems. So this chapter or this particular section is all about the converses of the postulate and the theorem that you learned in the previous lesson. So just to recall, a conditional statement is a statement that's written if P then Q, and the converse, not the tennis shoe, but the converse conditional statement is if Q then P. So we had a postulate called the corresponding angles postulate in the previous lesson. In this lesson, we have the converse of the corresponding angles postulate, which says if two coplanar lines are cut by a transversal, notice it doesn't say they're parallel. It just says that they're cut by a transversal so that the pairs of corresponding angles are congruent. If the angles are congruent, then we can draw the conclusion that the lines are parallel. So that is the converse of the corresponding angles postulate. So we're going to use the converse of the corresponding angles postulate to prove that the lines are parallel. So if you take a look at this example, they tell us that angle 4 is congruent to angle 8. Well, angle 4 and angle 8 are corresponding angles with our transversal T. And if angle 4 is congruent to angle 8, we can say by the corresponding angles postulate, because they are corresponding angles, we can draw the conclusion that line L is parallel to line M, because the postulate says if the corresponding angles are congruent, then the lines are parallel. Likewise, if we look at angles 3 and 7, they are also corresponding angles. So they give us an expression for angle 3, an expression for angle 7, and they tell us x is 30. So if we can show that these are congruent, then that means that the lines are parallel. So for angle 3, I'm going to do 4 times 30 minus 80, which is 120 minus 80. So angle 3 is 40 degrees. And then for angle 7, I'm going to do 3 times 30 minus 50, which is 90 minus 50, which is 40 degrees. So the measure of angle 7 is also 40 degrees. So that means that angle 3 is congruent to angle 7 by the definition of congruence. So the line L is parallel to line M by the converse of the corresponding angles postulate. So up above, I messed up. I should say by the converse of the corresponding angles postulate, that they are parallel. So we also have the converse of the alternate interior angles theorem, the alternate exterior angles theorem, and the same side interior angles theorem, which says what you might expect. If the alternate interior angles are congruent, then the lines are parallel. If the alternate exterior angles are congruent, then the lines are parallel. And if the same side interior angles are supplementary, then the lines are parallel. So our original conditional statements from the previous lesson, those conditional statements all say something about the lines being parallel, and then they lead you to conclude something about the angles. In these particular statements, the converses all say something about the angles, and then they lead you to conclude that the lines are parallel. It's the converse. So we're going to prove the converse of the alternate exterior angle theorem in this particular slide. So we have our statements, and we have our reasons. Okay, so for statement number 1, we know that angle 1 is congruent to angle 2, and that is given to us. Okay, angle 1 and angle 2 are congruent. Those are alternate exterior angles. We somehow have to prove that those lines are parallel. But I also know that angle 3 is congruent to angle 1, and that is by the vertical angles theorem. Oops, theorem. Spelled that wrong. Okay, so if 1 is congruent to 2 and 3 is congruent to 1, then by the transitive property, I can say that angle 2 or angle 3 is congruent to angle 2. That's the transitive property, transitive POC. And what kinds of angles are 3 and 2? They happen to be corresponding angles. So then I can say that means that line L is parallel to M by the converse of the corresponding angles postulate, which says if the corresponding angles are congruent, then the lines are parallel. All right, lastly, it says use the diagram for the given information and the theorems that we've learned to show that the two lines are parallel. So angle 4 is congruent to angle 8. I look at angle 4 and I look at angle 8 and I see what kind of angles those are. They're alternate exterior. So I say by the converse of the alternate exterior angles theorem, we can draw the conclusion that line R is parallel to line S. For this next one, the measure of angle 2 is equal to, I'm going to plug in 5 for 10 as it says at the end there. So I end up with 58 degrees for angle 2. And the measure of angle 3 is equal to 25 times 5 minus 3, which is 122. So now I'm going to go back up to my diagram and I'm going to look at angles 2 and 3 and I see they're same side interior angles. So the measure of angle 2 plus the measure of angle 3 is equal to 180. So by the converse of the same side interior angles theorem, theorem, I keep messing up this word, we can say that R is parallel to S. All right, so review these I can statements and make sure you at least understand and can recite what those theorems and postulates and the converses say. And also that you know when to use the regular theorems and postulates and the converses, and we will practice more in class. See you then.